At STP, molar volume of every gas at STP, that is at standard temperature and pressure, is equal to 20.4 dm cube or 22,400 cm cube. This is what we call the molar volume. And today we are going to be using this. We're going to understand how to apply it, how to use it to solve problem if there is a need for a problem that involves the volume of gases at any temperature. You'll be able to get this thing done. So we have a question on the board here. The first question says that if 500 cm cube of a certain gas weighs 1.43 grams at STP, calculate its molar mass, B, its vapor density. So that's what we're going to start from there. Now, as we have already noted, the volume of every gas at STP is equal to 22.4 dm cube. Now, this simply means that 1 mole of every gas at STP, 1 mole of every gas at STP is equal to 22.4 dm cube. Then, if it's 22.4 dm cube, then it means that we know that 1 mole of any substance is also equal to what? Molar mass of that substance. So in that case, if 1 mole is equal to 22.4 dm cube, then it's the same thing as we can also agree that molar mass is equal to what? 22.4 dm cube when you talk about it in volume, because we are dealing with gases. So now the question said calculate the what? Calculate the molar mass. To get the molar mass, now if we agree totally that 22.4 dm cube of any substance in volume is also equal to the molar mass, then we can use this to get what we are looking for. So let's quickly look at how we can solve this first problem. Let's look at how we can solve this first. The first problem says that now we have that from the question, it said that 500 cm cube, 500 cm cube of a gas, can call that gas, let's say the gas is what? X. Is equal to the weight, the mass is what? 1.43 grams. 1.43 grams. Now, what with that molar volume? We know about molar volume. Molar volume is always what? 22.4 dm cube. Actually, we're going to use it, since this one is in cm cube, we're going to be using cm cube. Let's convert it to cm cube. That's in cm cube. What it simply means is that 22.400 cm cube, so that it will be easier for us, of X. 22,400 cm cube of S will then be equal to 1.43 divided by 500 times 22,400 over 1. And this can go here. Then what else can go? Then let's see. Then we have 1.43 times 2 divided by what we have is 0.64 gram per mole. Or alternatively, we can round it up to whole number. We have 64 gram per mole. That's the answer to the first question we have. already solved here. So the next one we are going to do is to calculate the vapor density. Now to get the vapor density simply vapor density is always equal to half times what? Molar mass. Half times molar mass. That will give us the vapor density, because vapor density of every gas is 2 times molar mass or relative molecular mass of the gas, as the case may be. So when we do that, what we have here, the molar mass, we have it to be 64 divided by 2. That will give us 32. That is our vapor density. Now, the next one we have here, the next one we're going to be looking at is a bit different. This one talking about say calculate the volume of carbon 4 oxide liberated by decomposition of 20 grams of sodium hydrogen trioxocarbonate for on heating. We have a balanced chemical equation for that, and then every other thing we need is already stated there. So what else are we going to do here? To solve this problem, the first thing we'll do is to look at a close look at the balanced chemical equation will give us information that we need. That's one of the things we can get from chemical equation. Number one is that the masses of the reactant, the volume of the reactant, all those things can be seen in the word balanced chemical equation. In this case now, the equation says we should find the volume. The volume is what we're looking for. So from this balanced chemical equation, we have a sodium trioxocarbonate giving us water, and then have a gas solid. This one can always is also solid. Now look at what we have from this balanced chemical equation. What we can get from here means that because we are looking for volume, this is ideal environment at STP. At STP, it means that this one must be what, 22.4 GM3. That is what will be liberated if this sodium hydrogen trioxocarbonate will react. Now from this balanced chemical equation, we have the mole of what? Sodium trioxocarbonate that reacted. Now you know that mole multiply molar mole, and we know that, let me go back there. We have mole equal to mass over what? Molar mass. So if we want to get the mass, the reacting mass, it will mean that this will cross over. We have the mass equal to mole times molar mass. That's how we can get it. Now we have a molar mass. All these things will give us a molar mass of this sodium hydrogen trioxocarbonate. Multiplying it with the mole, which is the mole ratio here, we multiply with this mole, we get the mass reactant. So that is what I'm going to do here now. We know that the molar mass, to get the molar mass of this sodium, we have sodium hydrogen trioxocarbonate 4. Sodium here is 23 and hydrogen is 1. Hydrogen is 1. We know that hydrogen is 1. And oxygen is 3 here. 3 times 16. 3 times 16 will give us, I think, 48 plus 1. We have everything. When we add it up, we'll add up everything, we're going to get 84 gram per mole. So that is what we're going to get here. So the next thing we're going to do here is we'll multiply times 84. That will give us the mass that's reacting. They will give us something like, let me just do it with this. We'll have 84 times 2. That will give us 168 grams. I believe you are following. So what do we have? From this chemical equation now, we've been able to get the mass of the reactant of sodium hydrogen triazocarbonate that will react. I believe you're following. We have, that means 168 grams of sodium will give us sodium hydrogen triazocarbonate will give us what? 22, let's just use cm cube, that is 22,400 cm cube of what? Carbon 4. So now, what will these 20 grams give us? What will this 20 grams give us now? 20 grams we are looking at. So what are we going to get? To get it, what we have here will be 22,400 divided by 168 multiplied by 20. That will give us the exact thing that we're looking for. So we have 22,400 multiplied by 20 divided by 168. What we have is is equal to 6.7 cm cube. Alternatively, we can make it, okay, if we are to round it up to the nearest, if we round it up, we have a 6 cm cube. That is what we get. So this is exactly what you are going to get from this, and thank you for coming this far. If you're joining us for the first time, we want to encourage you to subscribe to our channel, and then if you have any question, feel free to ask your question. Leave your question in the comment section, and we'll encourage you to share and like our video. Thank you so much.